So the only thing you have to be careful about, this is very much like when we did polynomials, right? You just have to be careful about where there's a minus to distribute it. And now you just get your like terms together. I'm not multiplying, so none of that I squared, I cubed stuff is going to come into play. This is purely just get your like terms together. I can get all my real stuff together and all my imaginary stuff together. So what real stuff do I have at the end?
I plus 5.
What real stuff do I have?
3, negative 5.
Sure. So I got 3 and 7 is 10, minus 5 is 5. Just adding those numbers, guys. And then if I have 4 i's, minus 2 i's, minus 1 i, I got 1 i left. All right, that's it. It's just like I is x. The only difference is what's x times x? X squared. Can I do anything else with that? No. But what's I times I? I squared, which is, what's I squared? Negative 1. I love it. In that list of exponent stuff, I squared is the most important dude, and I'll show you why. Here, do what you think here. What do you think you should do here? Foil. I love it. Do it. You're like, well, I thought you just asked us what we would do. All right. Now you get what here? 30. Good, because we're multiplying now. Good. Now you have some obvious like terms, but then you also have something that you normally couldn't do anything with. But I is not a variable. It acts like a variable, but it's actually a radical. So what is I squared? Yeah, so I can rewrite this as 30. What's 25i minus 6i? 19i. Minus 5 times negative 1. Can I replace I with some? What is I by itself? What's I defined to be? The square root of negative 1. That's the basic definition of I. So you can't replace I with anything useful. Don't replace I with 1. Why would I call 1 I? I already got 1. I'm going to give it a different name. But I squared I could do something with. I squared is negative 1. So then I get, what's negative 5 says negative 1? So then I get 35 plus 99. Bam! So a complex number times a complex number has to be a complex number. What is happening over there?
So when it says I, we leave it as just I.
Yeah, because it's just a better way to write square root of negative 1. So if I had 7 pi, I'm not going to rewrite that as 7 times 3.14159. Why would I do that myself? Just leave it, stop at 7 pi. Pi is there for a reason, because it represents a weird-ass long number.
So when you have like that little chart, so I equals the square root of negative 1.
Exactly.
That's what it was.
That's what it is. That's why I squared is negative 1. Because when you square the square root, they cancel. So, by definition, I is the square root of negative 1. So what's I squared? These cancel. There. Okay. And that's what started the whole cyclic thing and all that kind of stuff. Okay. So what about... So this is just like polynomial stuff, right? The only difference is if I get an I squared or an I cubed, I know I can replace it with something. I squared I can replace with negative 1. I cubed I can replace with negative I. That's the only difference really between I and a variable in terms of working with them, is I can go further than normal. So what about this? Remind me what I is again. What do I be? What is I? It sounds so existential. What is I? My grammar is no good, but what is I? I is the square root of negative 1. It's a radical. What do you use to simplify this then? The conjugate. In fact, here we go. We're going to call it the complex conjugate because it's a complex number. But you guys, if I had 4 plus the square root of 2 divided by 5 minus 2 rad 2, what would you multiply by? 5 plus 2 rad 2. So what did I just do? I replaced I with rad 2, just to show you an example. So I is a radical. It's going to act the same way. So I'm going to multiply by what? 5 plus 2i. Okay, go ahead and finish that up. What is I? So on the bottom, you actually don't have to write these because you know you developed it so those cancel. Don't get too excited. They don't just always cancel everywhere. Right? On the top, what can I do with this? Yeah, I squared is negative 1, so that's really negative 2. 20 minus 2 is 18. What's 8i and 5i? 13i. On the bottom, I get I squared again is negative 1. Negative 4 times negative 1 is 4, plus 25 is 29. And just to show you, that's fine. If you stop there, I'm fine. But can't you do this 18 over 29 plus 13i over 29? Just to show you it is a plus bi. It is in the form of a complex number. Complex divided by complex is complex, complex plus complex is complex, complex times complex, complex. So you always have to be able to write it as a plus bi. How important is that? Not really, but it's related to this idea called closure. If I take two elements and I do stuff with them, it should still be in that set of stuff. So if you do anything with two complex numbers, they can only become another complex number. They can't become something else outside of that set. I went a little further than I should have. I'm sorry. You don't have to worry about that. Okay. So now we're going to see situations like, how do you think you would solve this equation? Let's start off nice. How would you solve that, do you think? Without factoring. Now, if I did factor this, let me bring this over. How would you factor this? How do you factor x squared minus 1?
X plus 1,
X plus 1, x minus 1. So what would the answers be? Negative 1 and 1. I love it. Now watch, from the beginning, there's a different way to do this. How do I solve any equation? I undo what's being done. I'm squaring x. How do I cancel that? What's the opposite of squaring? Square rooting. The opposite of squaring something is square rooting. So if I squared 4, I get 16. What do I do to 16 to make it 4 again? I take a square root of 16 to undo what squaring did. So if I square root both sides, I don't quite get all the answers, do I? I'm supposed to get what as answers? -1 and 1. So if I square root, I sort of took a shortcut. So I better put plus and minus to tell myself, I got to get both roots. Do you remember that problem we did where it said, what are the roots of 900? And it was 30 and -30. It's when I ask you what's the square root of 900, you say 30. That's the positive one. But this is saying, what do I square to get 1? Well, I square 1 or -1. Plus or minus 1. All right. So what about this problem? One. X squared equals -9. What do you do to both sides? Square root. The minute you put a square root down, you put plus and minus. It's related to what that guy was talking about, the fundamental theorem of algebra. I'm almost certain that I brought this up before. If I see a second degree, I should see 2 answers. Third degree, 3 answers. Some of those answers might be complex, though, so that's why they don't show up until we learn about complex numbers. So here I should get 2 answers. That's a plus or minus. What is the square root of 9? So what's the square root of -9? 3. No, come on, you guys are better than that. What's the square root of -1? Isn't square root of -9 square root of 9 times square root of -1, right? So what's the square root of 9? 3. What's the square root of -1? So since the square root of 16 is 4, what's the square root of -16? 4i. Square root of 36 is 6. What's the square root of -36? 6i. Square root of 81 is 9. What's the square root of -81? 9i. I love it. Those are all things we weren't able to do. What was our answer if I said square root of -81? Your answer should have been not real. And now it's not good enough anymore because we know the other kind of numbers. We know these things that we should call lateral, but we'll call them imaginary. We know those now. So now you can't say not real. I'm like, yeah, I know that. What is it then? So let's see if you guys paid attention. What's the square root of -25? 5i. I love it. So what's the square root of -16 times the square root of -25? What's the square root of -16? 4i. Square root of -25? 5i. And what's 4i times 5i?
20i squared.
20i squared. What's I squared?
-1.
There. That's the answer. I like it. I like it. Maybe. So you see how once we learn about I stuff, we can go back and say, oh, this is where it would have come in before, where we would have said no solution, or we would have said not real or something, then we can actually do it now, because now we know these extra numbers. And you're all like, I didn't need to know. It's too bad. I want to really freak you guys out. How do you factor x squared plus 25? Couldn't before. Now we totally can. Multiply that out. Check it. Multiply that out. Let me catch up to you guys. So we get x squared minus 5ix plus 5ix, so they cancel each other, minus 25i squared. What is I squared? -1 times -25? Check. That's how you factor it. Why couldn't we factor this before? Because we didn't know the numbers, that when you multiply it by itself, you actually get a negative number. Real numbers can't do that. 5 times 5 is 25. Negative 5 times negative 5 is still 25. You can't get a negative number out of those. But with complex numbers, yeah, you can. Totally. They complete the idea of numbers. Without them, it's incomplete. So I feel really happy to have been here for you when you got to this point. You learned all the essential numbers. There's more numbers, but you don't need to know. They're exceptionally freaky. They're in like other spaces and shit. Don't worry about it. Okay, all right. Let's see. So remind me, what's I to the 17th? Can you figure that out? What do you divide 17 by? Remainder. So it's the same as I to the first, which is I. So the answer to I to some power is it's I to the remainder after you divide by 4. Why does that make sense? Because every fourth one, it starts over. So I'm just seeing where it is in that cycle. The remainder tells me where it is. What's I to the 40,000th power? 1 total. Pop. If 4 goes in evenly, that means it's at the beginning. It's at 1. So I to the 0. 0 remainder. So it's 1. Okay, I like it. Okay. Last quick thing. Well, we'll do this more next time, but I sort of got into it a bit. So just let me see if you guys see the idea here. If I wanted to solve this, it's the same idea as before. It's just backwards. What's the opposite of what's the opposite of square rooting? What's the opposite of square root? Square. So again, what's the idea with equations? I do the opposite to try to free the x up. Where's my x? Stuck inside the square root. I got to kill the square root then. So I use the opposite function. If I do it to this side, I better do it to that side. So then what happens here? These cancel. Don't square this stupid thing. See how the square died? Gave its little life to free this dude. This dude is free. What do I get on the other side? 9. So I get 2x equals 10. I get x is 5. Yay! If I check it, twice 5 is 10. Minus 1 is 9. Square root of 9 is 3. Okay, I think that's enough. That's section 10.6, which for some reason I skipped. We did 10.8, which is complex numbers. We've got to come back and finish 10.6 and then get into chapter 11. We're not going to have class tomorrow, so I'll see you guys Monday after Thanksgiving. Have a good break. I know I will.